chemical reactions in a little bit more detail. And in the last video, we talked about chemical reactions being a sort of recipe for creating something new, in this case, the product that was being formed. So in this recipe, we have 2 hydrogens, 2 moles of hydrogens, and 1 mole of oxygens will produce 2 moles of water. Well, these coefficients right here, the 2, the 1 that's not written in, and this 2, give us a mole ratio. And that mole ratio, just like in a formula, has to remain the same. It's saying if I have 2 hydrogens and 1 oxygen, I can create 2 waters. Well, what happens if I have 4 hydrogens instead of 2 hydrogens? Well, if I have 4 of these hydrogens, then I can add 2 of these oxygens, and I will produce 4 of these waters. So this ratio 2 to 1 to 2 is preserved in this new ratio. Or I can have 8 to 4 to 8. The ratio is still preserved. This molar ratio from 2 to 1 to 2 or 4 to 2 to 4 is preserved. And that allows us to adjust. If I want to make more waters or more moles of water, I can just start out with more moles of hydrogen and more moles of oxygen. Okay, so what does that mean? That means we're going to get questions where they're going to be manipulating the number of moles that you are given in the equation. So let's take a look at this. And this question, it says, given a balanced equation representing a reaction, what is the mole ratio? Oh, there's that fancy word again. What is our question word? Is the mole ratio. The ratio of moles of CO to CO2. Well, how many moles of CO do we have? 2. And how many moles of CO2 do we have? 2. So the ratio of CO to CO2 is 2 to 2, or 1 to 1, if I reduce it. Okay? So the mole ratio is 1 to 1. Let me just add to this. What about if they asked you for the mole ratio of CO to O2? Then the mole ratio would be 2 moles of CO to 1 mole of O2. Okay, nice, easy, straightforward question. Keep going. Woo, I gotta erase that. Nice. Okay, let's come back here, pen. Alright, if we're given an equation, 1 mole of magnesium plus 2 moles of hydrogen chloride or hydrochloric acid produces 1 mole of magnesium chloride and 1 mole of hydrogen. They're asking me how many moles of hydrochloric acid are needed to react with 0.5 moles of magnesium. I think that's a 0. Let's make that 0.5 moles of magnesium. Okay? Well, right now I have a ratio here of, come here, pen, 1 magnesium to 2 hydrochloric acids to 1 magnesium chloride to 1 hydrogen. If I had only a half of a mole of magnesium, this ratio must stay the same, 1 to 2 to 1 to 1. If I have a half of a mole instead of 1 mole, I can react that with 1 mole of hydrochloric acid instead of 2. And I will produce only a half a mole of magnesium chloride and a half a mole of hydrogen. So this ratio stayed the same. 0.5 to 1 to 0.5 to 0.5 is the same as 1 to 2 to 1 to 1. If you want to do it mathematically, if you really want a definitive way to do it, you could take this 0.5 moles of magnesium and you can place it over the 1 mole of magnesium that's already there. And then you can set it equal to what you're looking for, over 2. And this will work every single time. You can have 0.5 over 1, 0.5 over 1. I put the 0.5, that's what was given to me in the formula, or in the question, over 1, because that's the coefficient it is right now. I'm looking for how many moles of hydrochloric acid. So I put my X over the hydrochloric acid, and then there's already a 2 there. So see how this is what was given to me, this is what I'm looking for. These two numbers came directly from the equation, and then I can solve it by cross multiplying. 0.5 times 2 is 1, equals 1 times x is x. So x equals 1. Just like I had figured when I did the ratio. 0.5 to 1 to 0.5 to 0.5. That's as hard as they're going to get. Okay, they don't get much harder than that. So let's go to the next question. Let's see what is in store for us, because I didn't do these ahead of time. Okay, consider the following equation. 2 moles of C2H6 plus 1 mole of oxygen, so 2 is to 1, yields 4 moles of carbon dioxide and 6 moles of water. When 4 moles of C2H6 are burned. So instead of 2, I'm doubling it. So 2 is to 4. I doubled this. The number of moles of CO2 produced will be, so instead of 4, since I doubled this one, I have to double this one. 8 moles of CO2. So let's just continue. We can just put the rest of the ratio in. So even if they asked you about oxygen or water, you would be able to do it. If this was doubled, then this was doubled. This is a 1. This has to become a 2. And this has to become a 12. The ratio stays the same. 4, 2, 8, 12 is the same as 2, 1, 4, 6. When you're writing a balanced equation, you must have the lowest whole numbers. And I've seen people lose points on Regents exams because they balanced it correctly, but they didn't reduce it at the end. So be careful of that. Alright. Hopefully this little video helped.